So, after a little bit of relaxation, we can now step towards the activities concerned with models. That is our part for models to be used and to be developed. So far we considered models as such and finalized the first and the second part of the lecture by stereotypes of models. Now we are turning towards activities. Models have to be utilized and to be developed. The development and the utilization is typically a process that can be decomposed in the number of activities. At the same time, models are typically consisting of a number of tightly associated models. That means we are now referring to the notion of a model suite. See section 9. We will now introduce a general approach to model suite development. We first consider only models as such and will later turn to model suites. When we have been writing the book on MMM, we had in mind 4 or 3 different sides of what we do with models. One is to have a model. Another one is to develop a model. That means to model. And the third one is to utilize a model. And finally, we want to have some kind of understanding what it means. Modeling as an art, as a science, as maybe a culture. In German language we have it simpler. We use the word Modell, modellieren und Modellierung, and for this reason we might have a problem of translating the MMM notion to an English version. So we use maybe 4 different sides. To model and to utilize are activities. Activities with 2 different facets. One is model deployment based on activity. So we need models how to deploy a model. And another one is model development based on activities again. And now we need to know what that means. In this case we can say, okay, fine, model development based on activities is of course abstraction, is some kind of method canon we have to use, and is of course what we have to understand of model development, or for model development. Model deployment is also based on activities. We will come back to model development in section 12 and to model deployment in section 13 of this course. Let us consider one typical example: scenarios for mathematical models. We have a classical typical mold that is a little bit of extension what mathematicians understand. We start with some kind of situation model. We next develop some kind of real model by utilisation. Then we use some kind of formalization method and develop a corresponding model that can be handled really by mathematicians. Then we investigate the mathematical model. Then we evaluate the solution. And finally, we evaluate the solution for the real or the mathematical models. That means in this case, we have at least 6 steps as a procedure how to deploy, how to use a model, and how to develop a model in the mathematical modeling mold. The mathematical method as a mold is mainly concerned with some kind of problem. It uses a domain situation model. It uses a formal mathematical model, solves the task, verifies it, and of course is based on dependability and faithfulness. The mathematician, however, is not interested at all what kind of problems are considered. It is mainly the topic of handling the model for a problem solution. In computer science we have a similar picture. We might have maybe less than 10 methods for modeling in computer science. It is again based on composition, recomposition, It might be extrinsic and intrinsic, especially for the deep model. It might be based on some kind of modeling method or mold and methodology. It can be also based on some kind of technology and techniques. Of course, we focus and scope, orient, whatever is represented, and we can use, since we are mainly language-based, semiotics for representing things. That means in this case we have constituents of the activity to model. We have some aims and some hopes for the target outcome. We have an integration and mapping of models depending on their correlation and cohesion. The detection, description and experimentation of laws will be somehow an underpinning. And of course, models are evolving. For this reason, we have to consider some kind of model ecosystem. Models are instruments, is our main claim. That means in this case, they are representing something for somebody, are addressed to somebody, somehow are fitting the goal and purpose so that they function in a proper way. They are based on some background within a context. And for this reason, models are deputies of something that are purposeful, maybe can be purposefully used in scenarios, supported by a corresponding method where they provide a surplus value. That means they are thus instruments. For this reason, we want to turn now maybe better to the instrumentation function of a model. Oh my goodness, then we have maybe too many different scenarios to consider. Maybe for problem solving functions, for engineering functions, for science functions, for social life functions, as we have been already considering in our aspect representation in chapter 5 and chapter 10. That is a bit, that is a lot. Maybe we can restrict ourselves a little bit. The model can be used in a variety of ways, and the model will be formed according to the somehow foreseen usage. That means in this case we can orient the model building on the instrument functions in those scenarios. An instrument is a device that requires skills for proper use in a given scenario. As such, it is a means whereby something is achieved, performed, or furthered. Second, one used by another as a means or aid. Third, one designed for precision work. And fourth, the means whereby some act is accomplished for achieving an effect. This instrument definition, let's say this instrument notion, is of course not covering all possible cases of instrument usage, but I think it covers the main instrument usage for models. An instrument can be used in several functions and scenarios. For this reason, we have to consider also the change of functions, and the quality of model determines its utility, for instance, its usage, usability, and usefulness. There is a big claim written by Pellman Box. All models are wrong, but some are useful. My belief is a different one. Most models are somehow coherent, and they are also useful. We have biases, beliefs, paradigms, postulates, cultural theories that are, of course, determining the kind of the model. We have assumptions, a hidden background, a hidden agenda. We have also languages that are used. We have a school of thought, style, pattern, and common sense that are somehow determining which kind of model is acceptable for our community of practice. We have guidelines, practices, trainings, experiences, methodologies, and models are typically also laden. However, as an instrument, they integrate and they bring some kind of tacit knowledge that is behind the usage of models as an instrument. For this reason, we might have now to consider different kinds of models, depending on the specific function. So that means in this case we should determine what kind of function, what kind of model play in what kind of scenario. We can have a number of stereotype scenarios: analysis, communication, construction, problem solving, programming, search, socializing and understanding, to name only some of them. I will show here only some of them and concentrate on main scenarios we have not yet considering in this module. As already said, in the mathematical method we have something like a situation model. The situation model can be somehow based on a perception model. It is somehow based on some kind of experiment, formal and explanation model. We map the formal model to some kind of mathematical model, and the experiment model and the mathematical model we map to some kind of simulation models. In any case, a model comes typically as a model suite. That means in this case each of the models has at least also some kind of informative, declarative, or more generally representation model that is used together with the model. The model, however, is all the time based on some kind of perception models and maybe also on domain situation models. Okay, let's turn to a typical function in scenarios. In a communication scenario, the model is used as some kind of instance of transmitting. Of course, this depends on a sender and a receiver, on the form the sender provides the model, on the form that the receiver accepts for the model, and on the sender-receiver relationship. That means in this case we should know how in communication scenarios a model can be used. That depends of course on the culture, context, community, on the scope of origins and the profile. Models for communication can be somehow mapped to the theory of communication acts. That means in this case back to Searle. Then a model provides some information that is transferred from the sender to the receiver, that is received by the receiver, that is recognized and filtered against the knowledge and experience of the receiver, that is understood by the receiver, and needless integrated into the body of knowledge and information the receiver has. That means to model can be understood as a communication act in a social society. That means in this case we can use maybe Searle's speech act theory with different kinds of uses: phonetic, phatic, rhetoric acts. Some of them are maybe locutionary, illocutionary, or perlocutionary. We have maybe the foresight model that we can use, developed by Thun. The model developer, the model layer, the self-revealing layer, the relationship layer, and the appeal layer. We can also consider them, let's say, the meta layer, the self-revealing layer, the relationship layer, and the appeal layer. We can generalize it to the cooperative principle within a community of practice. We can also use some kind of nice, let's say, communication principle, let's say politeness principles within a community of practice. If you go back to Liege, we have the maxims of tact, generosity, approbation, modesty, agreement, and sympathy. To Greece I will come back in a minute again. As already considered in communication, we have dialogues, discourses, community exploration, debates and diatribes. We have the world that Alf is living in, the model space of Alf, and the model space of Bertha, and these model spaces somehow can be mapped to each other in a communication act. And of course they have to be understandable by the other, so in this case we can go again back to sending, receiving, somehow accepting, somehow integrating, as we did it for the model information. This is repeating what we have been doing already in section 8 on conceptualization. Let's go for another scenario, search models. Search is one of the main activities in most sciences, and for this reason maybe we should consider it in a special form. We have a number of search patterns we can use in this case, and then a model should be somehow completed in such a way that it is supporting these search patterns. Searching can be querying. Querying is the best thing what we do in our database area. It can be also seeking for information on the data, for instance. It can also be questing data formally. It can also be, let's say, ferreting out data that are necessary for some process, or searching by association and drilling down, or casting about and digging into the lake of data, or simply zapping. Depending on which kind of pattern we have in mind, we have also the pattern of the search request result. We can map it, and the model we can represent by question and answer forms. A question form states what is the matter, in which context. And it is of course issued by a user who has a profile and a portfolio, and the user uses a query language within a certain namespace, and in this case we can map it somehow like we did in chapter 4 on language issues based on semiotics, and of course maybe differentiating between the normal and the deep model. An input form is now mapping this question form towards some kind of handling facility. So in this case we can say fine, the input form specifies the question word field, as we did in the W*H framework. It uses maybe some pattern, it uses a collection of database use, it uses a protocol, it has controllers, has some supporting means, and of course might be based on defaults. That means in this case we map now our question form to an input form. We can do it also graphically, as we did it with IDF, a user question based on a pattern, based on word fields, with a user profile and the portfolio results in some, let's say, answers by some supporting means. That means in this case we can have some kind of generic search meta model. We start with initialization, we consider the background, we consider the ansatz, the agenda, and the generic normal model. We consider the initial normal model with all the algorithms we can have in mind, and have as a result a specific model suite that represents what we have been searching for. The output form is now the other side. Having in some kind of question form, of course we want to have some output, some search result. That means in this case we have a B model based on what we are searching for and what will be the result. And the output form represents which kind of results we expect, how we compute the result. That means we have an answer style, we have an answer collection of database views that are supporting us, we have controllers again, metadata and context pattern, and we have supporting means and defaults, as we have had already for our query and question forms. In this case, we can say, okay, fine, our search request is nothing else as some kind of representation of the style of search, like we do it here with the 7 different styles of search, to some kind of answer. So it means this, in this case, the model has now 2 aspects: question and output. Okay, in this case we can maybe also go to another kind of model, the models that we are using for analysis, for instance for data mining. Then we have 6 classical concerns considered in the literature: knowledge space and model background, concept space, data analysis algorithms, hypothesis and assumption spaces, and of course acceptance and success criteria. I think we can map it better to some kind of reconsideration: application domain and problems and users, context, technology, techniques, the data space, the metadata, the data quality, and finally we have the representation of solutions, for instance by models. In this case, our data science space is nothing else as some kind of classical way how to represent different data mining aspects by models. Furthermore, we might consider that we have something like a domain world, and we would like to have some kind of insight into an augmented domain world. That can be supported by a model world and by an augmented model world, and is of course using, if we especially use inverse modeling methods, by a data perspective, by the data world. That means in this case we have an application space, a model space, a data space. Another kind of model will be the model that is somehow supporting problem solution. In this case, we can start with a problem space specification. The general setting using the POIA framework would be problem, context, carrier and language, and solution, where the state space somehow should map the initial state to some goal states. For this reason we have actions for moving from one state to another state. Hopefully the actions can result in reaching the goal states. We might have also a goal test, and of course in this case we can base our model on a problem solution controller. A typical example of a problem space is, let's say, a problem posed in some kind of, let's say, known scientific prose, with some kind of background of the problem, similar to the model background, with some translation into the language of the discipline, with some inferences of the parameters and variables. Then we determine the relationship between the given quantities, we determine the development of a representation model, we determine the problem solution, we demonstrate the solution, and we explain and explore the potential of our solutions. This is nothing else as some kind of generalization of the mathematical mold we already considered at the beginning of our lecture here. The solution space specification can be now based on the definition of the solution, maybe on some illustration of the solution, maybe also on some examples, and we can also use some kind of pattern used for the solution. It can be extended by required behavior, commanded behavior, information display, simple workspaces, and transformations. Again, we have a kind of a model, of a very specific model that is used for problem solving. Maybe back to one remark. In problem solving, we expect that our problem space of the origin is invariantly represented in the model, and in such a way that the model solution can be mapped faithfully back to our origins problem space. Okay, let's turn directly now to activities. Activities for the modeling and utilization methods. The modeling act is nothing else as a generalization of the speech act based on a selection construction of the appropriate model, depending on the task, the purpose, depending on the function and the instrument, especially being in scenarios. It should, of course, be based on some kind of professional work. That means we should have some kind of workmanship on the model detection of additional information. And of course, we should have an analogy and adequacy of the model. And we should use the model for our system understanding, system building, system development. It can be based also on some kind of quality support. We can say, okay, fine, we have a rule system, as we already demonstrated in the second lecture for entity relationship modeling. We will turn back to it in a minute again to show how this methodology can be somehow supported. We have a framework for practical utilization. We have specific techniques. We have maybe also methodological frames. And we might have also restrictions. That means in this case we can map it now to some kind of engineering activity. In this case we have partners, mainly coming from our community of practice. We have aspects to be represented. We have finally a work product, maybe a number of work products. And we have, of course, resources. Amongst the resources, the most important are, of course, our origins. That means in this case, we want somehow a support for model development and model utilization. The problem is, of course, that sometimes people say, okay, fine, we need to reduce complexity. That is not the main issue. The main issue is to have an appropriate focus with an appropriate analogy. And of course, we would like to have some kind of dependability. So, the modeling issues are now nothing else as what kind of perception we are using. Maybe it's bottom up or top down, depending on how we work in modeling. We have some language-backed support. We have some categorization. We have a representation in an appropriate form by the corresponding model. And of course, what we would like to have, we would like to have a high potential and high capacity of our model. That means high competence. We would like to reduce our uncertainty. It should also be support us during evolution of models. In this case, you can say, okay, fine. Let's look again for the search pattern. In this case, you can say the search pattern is supported by a collection stereotype of modeling. Similar what we are using in our database research. Select from where. Select from some kind of reference frame. This is similar to what we see in other sciences. I've wrote here as an example astrophysics. We start with an ensemble of potential model components, somehow taken from reference models, from some kind of astrophysics ensembles, often tool-backed with specific deep models, often based on some kind of select aspects, and of course based on some kind of composition of the structure of the normal model. The deep model, however, is already given somehow, and for this reason we need to have a composition of the deep model and the normal model. And we might have to choose among representation variants for the model. That means in this case we have some kind of specific pattern or stereotype that we can use depending on the kind of the model. From development of models, we might use methods known under the name meiotics. I will come back to it in a minute. We might use problem solution spaces. We might turn to model suite development, or to reference modeling, or to generic modeling. Meiotics was a method developed by Socrates for asking questions for clarify what is a real issue. And he said, okay, fine, let's do it like we do it whenever we want to investigate a certain behavioral pattern, let's say, of a human body. In this case, we can ask corresponding questions in a corresponding sequence so that we have the best effect of our model development and the best effect of our model utilization later on. Okay, let's make it or base it on an example. I turn to my area, to database schema development methodologies. We can have, let's say, a longer methodology consisting maybe of 18 steps or so, where we define first the scope as the area of interest, we define the things of interest, we analyze the things of interest and identify the corresponding schema types, we consider hierarchies so that we can handle those in a proper form, we somehow try to dig out relationships between the types, we determine characteristics, we might identify static and reference data, we might now obtain a set of, hopefully a small set of sample data, we might go for reviewing the code and kind of data so that we can use or reuse whatever has already been done, for instance using some kind of ISO codes. We should look also for specific associations, typically are has a, is a. That means in this case we should have a handling mechanism. Mainly the handling mechanism will be based on hierarchies, and for this reason we can use it somehow in some kind of specialization generalization framework. We might gather the relationship types. They are based maybe on something. We gather whether the types are abstractions of others. So in this case we can have some kind of cluster representation. We go furthermore with defining the main identification for all objects, for all types. We try to avoid surrogate keys because of they are artificial, and for this reason we might have a problem later to using them properly in the world of the users. They are very useful in the world of the database system, but in the world of the users they don't have really a right, let's say, meaning. We confirm the first draft against the sample data. We review the business rules with users. We obtain from the users some representative inquiries for the database. Then we review the step 1 till 9 for, let's say, proper development, proper schema, proper views. So in this case we use our neighbors, our community of practice, and try to review whatever has been done in the first 9 steps. Then we define user scenarios and step through them with some sample data to check whatever is somehow supporting. In this case, you can say, fine, this is nothing else as some kind of scoping and restricting the model purpose, the model scenarios, the model deployment cases, and in this case we base our solutions on some kind of perception model. We explore the perception, maybe against the situation model if it is available. We try to make clear what to model. That means we use monstration methods. We extract the main ruling and relevant typical parameters with impact of other models. Then we have some kind of controlled amalgamation. We have maybe some plausibility. We look for typicality. We look also for potential construction expressions. And finally we use some construction expressions, some amalgamation, some formal method or model formation and formulation. Okay, fine. That means in this case we can now turn to somehow the story space of modeling. So far in our method we have been showing that the activities can be according to the kind of model, that means according to the instrument function somehow given. Now we have developed a number of activities. Maybe we should come back to it in chapter 12 of this module, and then we can go now for the scenes and the model journey in scenarios. A model is typically not used only in one function, but it is typically used in several functions, and it can, the object especially, can be a model at a certain stage of our scenarios, and in another stage it is only an object, and later it becomes again some kind of model. A typical case is, for instance, our development in the database area. We start with a model that is supporting construction of databases. We use this model for support of evolution, and we use this model later for documentation, whatever has been implemented. That means we have already 3 different functions we have been using for our models. That means in this case we have some kind of model journey. We can say, okay, fine, the journey of a model is some kind of Odysseus of an object. It can provide a utility, it can be a production model, it can be a worship model, it can be a post model, it can be an illustration exhibition object, and later it might become again a representation model or a demonstrative model. So then in this case we have nothing else as what we have been already considering for story spaces, a space of mini stories that somehow defines the model journey. So in this case we can use our storyboarding language to say, okay, fine, a model is used in some model scene, and with my model experience, my input for the scene, I can now have another scene and the transition from one scene to another one. And what I do in scenes is mainly I'm using my model experience, using the input for the scene, and develop something for the enhancement of my model. It can be controlled by the landscape, by strategy, tactics, and operational pattern. And of course, the model is involved in this kind of processes. For instance, turning back again to search, we can derive, let's say, some kind of search request. That means in this case we are somehow developing the landscape. Then we can go as a next step to derive a search stereotype. That means we are framing. Then we go next to derive some kind of search pattern. That means it's nothing else as configuration. Then we might develop an extract, transform, load requesting mechanism, and finally we deliver our model. Of course, in this case we have a lot of freedom to move from one bubble to another bubble, depending on which kind of search form, which kind of search stereotype we are using. Going from direct querying down to zapping and browsing. That means in this case we have a number of specific models that should support all these different search steps in our search space. We can furthermore go, let's say, to the classical way how we do or apply the search pattern or the model development pattern for conceptualization. That could be based on the meiotics approach. We go with the concepts, we request maybe some kind of differentiation, we understand and explain, we evaluate and select, we have some kind of concept description, we have a concept justification, and we have some kind of experimenting and testing, and maybe later we can apply the concept. That is somehow similar to the mathematical mold we have been considering at the beginning. Okay, let's now turn only to one issue that should be considered before we go to chapter 12 and chapter 13 evolution, integration, migration, modernization of models. There is nothing else as a support for the model journey. A model can be based as or developed as a description model, later used as an explanation model, or as a prediction model, or as a control model, or as an invention model. In this case, we have something like this spiral meta model toggling between macro and micro levels and going up and down for the model development. We have, however, to consider that solution and problem spaces are typically somehow providing a number of conflicts. For this reason, we have been using already Grimer's approach for the tension fields. We have positive terms and we have negative terms. And of course, they are somehow interrelated. We have examples of positive terms, let's say a cat, and maybe a negative is a dog. So in this case, they provide something like a simple implication on a generalization. We can say, okay, fine, cats are maybe wild animals and dogs are domestic animals, and there's an interrelation of that. That means Grimer defines so-called semic units. That is an analogy to phonemes by maybe a bundle of themes. That is an analog to distinctive features. In this case, we can say, okay, fine, we have now a way how we can even map our model evolution to some kind of classical understanding of development of a society. We have a state change, and we have a society, we have drivers, and we have maybe some receivers, and maybe other also members of our community of practice. In this case, we can say, okay, fine, a model, let's say for analysis, maybe for causes and effects, is nothing else as we say, okay, fine, there is some state change, like we have it already for evolution. Why we should have an evolution? We have some kind of transformation, and finally we can somehow reflect and respond to what we have been developing. I mean, in this case, we have some kind of cause-effect model approach. In a similar form, we can handle integration of models. Integration of models can be done in a functional or in a structural way. We have maybe some mappings, maybe we have only analogies. The mappings are based on some, let's say, level of data, micro, meso, or macro. We might have some kind of transfer of the same content of a model by an infomorphism. We have some kind of function integration, and we have some kind of constructor integration. We have been already considering this in the chapter on model suites. As a last remark, modeling is typically a teamwork. A team has typically a different view on the state of affairs, on the world that is generally done. A team consists of members. They are typically within our community of practice. And the team uses very different theories. That means in this case we have now some kind of negotiation and agreement within a team, somehow to enforce and somehow to be to use. Okay, let's summarize this part as an introductory part to the activities that are modeling activities. Models are instruments, therefore we need somehow a methodology, a method framework for developing the model. Depending on the kind of model, we developed here a number of methods for modeling activities and model utilization. That means in this case we have been using a trick. The trick is to separate different concerns and to separate models into different kinds of models that have a number of, let's say, generic structures and functions underneath, and we can use it so. And then in this case we can say, okay, fine, it is nothing else as having some kind of modeling matrix and having some kind of thought style, context, community habits, or more general a background of the model. Modeling activities are typically based on modeling acts. Modeling is a specific form, and we may thus develop workflows of modeling activities which are based on such steps as decompose and extend, abstract and refine, validation and verification, equivalences, transformation techniques, pragmatic solutions, and last but not least, this domain-specific solutions and languages given by an application and implementation domains. That means in this case the act of modeling is based on an activity that is characterized by the work products, by the aspects, by the resources, and the partners. That means in this case we can use an engineering framework. Additionally, we might extend the characterization by activity goals and intentions, by time span and restrictions, and by obligations for later activities. We might distinguish a number of activities and acts, such as understand, conceptualize, abstract, define, construct, refine, document, and evaluate. These number of activities are nothing else as macro models of activities. And model activities should be governed by good practices, which can be partially derived from modeling as an apprenticeship or modeling as a technology. Okay, this concludes now this chapter. The next chapter is now going for methods for model development. In this case, we should show which kind of functions are played in which scenario, which kind of activities, which kind of story spaces we are using. We might distinguish methods for green field development and methods for brown fields, it means extension development. We might have also sketches of to model, and we might use some model composition methods. So thank you for the attention. I hope it was useful. And now we can step for the hunt for model development.